Alright, these are your notes for 4-3 and 4-4. Pardon the look, it's Crazy Hat Day for our Red Ribbon Week. Alright, we are going to be writing functions. Your essential question for writing functions as well as graphing functions. Your essential question, there it is. Give a real-life situation that can be described by a function. Explain which is the independent variable and which is the dependent variable. Give a real-life situation that can be described by a function. Explain which is the independent variable and which is the dependent variable. All right? And let's talk about independent and dependent variables first. Okay? We have, when we're graphing, we've got x values and we have y values. And those two are always constant in every coordinate graph we ever do. But they can be described in various words. We have all kinds of different terms that we use for that. But they're x and y. Remember, they're written in coordinate as x, comma, y. So our x values can also be known as the domain if it's a function. Okay? Our x values are also known as just x. Okay? And then it's also known as the input. Okay? It's the value that we know that we put into the equation or into the function to find an answer. Okay? It's the input value. The input. Okay? The x value is also the independent variable. Okay? So that's how I like to remember. The input is the independent variable. That's how I remember which one's which. Okay? Independent is the input value. It comes first. Okay? Now, when we're calling our x value domain, our y value is known as the range. Okay? If we're talking functions, x is x, and our y is f of x, or a function of x. Okay? Or a function where we've inputted the x value. Okay? If x is our input, y is our output. Okay? We put in the value of x to get the y out of it. Okay? Our independent, and then we have our dependent. Okay? In real life, a situation example is, if I don't eat, I get cranky. So the independent is if I don't eat. I get cranky is the dependent, because I get cranky because I didn't eat. If you can state it as something that happens and then this happens, the independent is what happens, the dependent is the result. Or if you say something because something else happened, the what happened is the dependent, the because is the independent. Okay? So those are some examples for you. All right? A little visual that I like to use, this helped me understand domain and range and input, output, and functions and all that kind of stuff, is I looked at a little function machine. I am not an artist, so this is my machine. We have a little input. Okay, there's where I put stuff in. And there's where it's going to come out. So this would be my function right here. F of x, that's my function. Or I might write it as, if my function was x minus 2. Okay? And drop inside here, if it were a machine, you'd be dropping in coins maybe, and out comes candy. Or it's one of those claw machines, you dropped in a token and out comes a prize. Same thing, I drop something in, something happens in the machine, and something comes out. So if I were to drop in, say, an 8, that's my input. 8 minus 2 would be 6. So out would come a 6. And that would be my y. Or my output. Okay? This would be my input. Also known as my domain and my range. You're independent, something happens. I can put this in. Okay? Nothing's going to change to what happens to these numbers. They come in. Nothing changes them. They just go in the function. These numbers are dependent on what you put in. What you get out is changed by the function from what you put in. So that's independent and dependent variables. Now let's talk about using a table to write an equation. Okay? If I have a table, I'm going to show you the easiest way I've ever learned to write it. And this works whether you have x and y, or you have f of x and x, or you have n and y, or n and x. This works no matter what, for whichever table kind you've got. Alright? So up here I've got my x, or my input, or my domain. Okay? Remember, domain and range only works for functions, but that's where it goes. And I have my y value. Okay? I'm going to use two different colors here to help us out. So my x value is 1, 2, 3, and 4. Nice and easy. 1, 2, 3, and 4. Now, for the method I'm going to show you, which gives you the easiest way to understand and it's the fastest way to write the equation, you need to have x be 1, 2, 3, and 4. If it skips any numbers, you need to figure out what those middle values are before you can write the equation using this method. Okay? It's the shortest method. That's why I like to use it. So my y values are -2, -1, 0, and 1. Okay? So from here, I'm going to determine what value goes from each y value. Because this is the first value, second value, third value, fourth value. Okay? So to go from -2 to -1 was a +1. To go from -1 to 0 was a +1. Okay? To go from a 0 to 1 was +1. So I can see that every time I'm going up, I'm adding 1. Okay? I'm going to go back, and I'm going to add an extra little spot on my graph here. Little dotted lines here. Nice thing about dry erase, you can just erase them. Little dotted lines, and let's have an imaginary 0 here. If it was a graph, you would have that anyway, because it would just extend the line. So if I know it's +1, +1, +1 every time, if I go backwards, I know this number has got to be -3. Because to get from -3 to -2 would also be +1. Okay? So I like to call this my 0 value. My 0 position or my 0 step. Okay? So if you were doing like in, this would be the 0 position. Okay? Not quite the line leader, it's who came in front of the 1. Who came in front of the first number. So now I'm going to use this information to write my equation. I know it's going to be y equals something, because that's what you start. Y is our output. This number right here, whatever it is what goes in front of the x. Okay? This number right here is what gets added on, or in this case subtracted because it's a negative. So I'd have -3. Now this isn't an appropriate written graph because we don't need this 1. So I would erase that, and it would just be y equals x minus 3. Okay? This method works for every kind of graph, every kind of table you get, as long as it goes 1, 2, 3, 4. And then when you have tables, you can always add those numbers in by doing a little adding or subtracting. Another method you could have done that would be a little bit easier, maybe a little bit quicker, I find this pretty fast, is you could also go, okay, well, how do I get from this number to this number, or this number to this number, and do trial and error. Plug and chug. Plug in a number, see if it works. Well, I could go 1 times -2, I could go 1 minus 3, and figure out which one works for everyone. Okay, but that's a whole lot more math, which is why I like to do this method. Okay, so that's writing functions or equations from a table. Okay. Now, if I actually wanted to solve a function, maybe I'm given f of x. Okay, remember that's the same thing as y. F of x is the same thing. Okay? It's just a fancier way of writing it to know that it's not just an equation, but it's actually a function. Okay? If I wanted to write that, I might have f of x for when x equals 6. Okay? So let's say I have, I'm looking in the book example, so I have f of x equals 5x. That and y equals 5x are exactly the same thing. You solve them exactly the same way. This is just telling you that it's actually a function, okay? Not just an equation. All right, and then the question goes on to say, find f of x when x equals 6 and x equals 7.5. Okay? So that means I'm going to solve this problem twice. I'm going to plug in 6 and I'm going to plug in 7.5. So I get f of x equals 5 times 6. So f of x equals 30. Okay? And I could write that as an ordered pair, 6, 30. So when x is 6, the output is 30. And then I could do another one, f of x. I have f of x, where equals 5 times 7.5. Okay? This is where you plug in your calculator, because you're not going to know this from your head. So you've got 7.5 times 5. You get 5 times 7 is 35, plus 2 you get 37. So you get 37.5. So then that means you could write it as an ordered pair. When x is 7.5, your output is 37.5. And those would be your solutions to this function when these are the answers. You can also take this information and put it into a graph. Okay? If you're given a function, let's say y equals 2x plus 1. We have y equals 2x plus 1, and you're asked to graph it. The first thing you need to do is you need a set of ordinary pairs, a set of coordinates. You can also plug this into a graphing calculator and it'll give you the information. Okay, that's the shortcut way. And you do get a graphing calculator on your Algebra EOC. Alright, so you're going to want to know how to do that. But by hand, make yourself a table. You have your x values, you have your y values. And pick any x values you want if it doesn't give it to you. If it gives you a domain, use that. But if it doesn't, pick at least 3 numbers. Okay? 3 numbers make a line, so that way you can have 3 dots to connect. Alright? You can also do 5 if you want. But never just 2 and never just 1. So I'm going to pick -3, 0, and 3. Okay? This gives me a good range. I can see both sides of the origin, so I can tell if it's a curved line or a straight line. Then I'm going to solve. Okay? So I'm actually going to scoot my y over here, and this is going to be where my function is. So I've got 2 times -3. I'm plugging in the x value for x, plus 1. Then I have 2 times 0 plus 1. Then I have 2 times 3 plus 1. Okay? I'm going to solve these. 2 times -3 is -6, plus 1 is -5. 2 times 0 is 0, plus 1 is 1. 2 times 3 is 6, plus 1 is 7. Okay? Then if you were to write your ordered pairs in your table, you have your x, y, you'd have -3, -5, 0, 1, and 3, 7. Okay? From there, you can now graph the information. Okay? You can use graph paper. You can actually go online and it'll print out pretty little coordinate grids. I believe I've also left those under handouts on the website. If you look on handouts, there should be some graph paper and just a sheet of coordinate grids. Looks like this. So I've got, my biggest number is 7. So 1, 2, 3, 4, 5, 6, 7. That's -7. Make this a little longer. 1, 2, 3, 4, 5, 6, 7. That's +7. Biggest, I'm going to do the same thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now I can graph my line. Okay? I've got -3, -5. So 1, 2, 3. 1, 2, 3, 4, and 5. And then 0, 1. So 0, 1. And then 1, 2, 3, all the way up at 7. And there it is. Then you connect the dots. You can use a ruler, or if you're lazy like me, just a sheet of notebook paper, turn it on its edge. Always, always, always extend your line past your dots and add your arrow, because you did not use every possible point of X. Okay? So that's how you graph. Alright. If you are using a graph, and you already have the graph and you need to go backwards, this is how you do it. Find some dots, write down the ordered pairs. Okay? And that would be the values. Good luck with your notes.